All right, so in this module, we're going to go over an example of these continuous cooling diagrams. And what we're going to look at is we're going to look at a steel alloy represented by the continuous cooling transformation, or CCT diagram shown here. And what you're going to do is describe the microstructures provided at the following cooling rates. So cooling rates slower than 0.006 Celsius per degrees Celsius per second, between 0.02 and 0.006. Another one between 0.3 and 0.02 degrees per second, one between 8.3 and 0.3, and then the last being faster than 8.3 degrees. So see if you can come up with what microstructures would be like in each one of these cooling ranges. All right, so we're back and we're going to look at each one of these ranges. And what I'm going to do is I'm going to draw on the next slide that you'll see. And we actually looked at this in the previous module, so you might already have the answers, but let's go ahead and do this one together. So the first one was asking you about the slowest possible cooling rate, which was slower than this number here, right? So if we do that, if we're at some cooling rate that looks like this, right? So the first thing that we pass through is this austenite to ferrite, so we would expect ferrite. And then the second line represents the traditional austenite to perlite range. And then we cool down. And basically all we have for that first one then is ferrite and perlite. So we'll go back here and F plus P. So spell this out when you do these types of questions. So F plus P, sorry for that. Let me erase it. There we go. Oh, maybe. All right, I'll just start over on that one. So F plus P. All right, so the next one is between 0.006 and 0.02. So that would be in here, right? So again, we're going to have ferrite. Again, we're going to have perlite, but we don't finish forming perlite because we go through this black curve. And so the next thing would be bainite, right? And we are never really finished forming bainite, and so there's the potential here to actually form martensite as well. So this one is very busy. It has martensite, ferrite, perlite, and bainite. So it's a very busy one. So let's put that one in there. Martensite, basically everything other than austenite. And it doesn't matter what order I have it in here. And then ferrite. All right. So the next one was between 0.02 and 0.3. Let me just double check. Yep. So we're talking about cooling rate here. So here we do form ferrite, but we don't start to form perlite because that's over here indicated by the yellow line. But we do form bainite, and then again, just bainite really doesn't have a completion area here, so we also form martensite as well. So that means martensite plus bainite plus ferrite. So let's go back. Martensite plus bainite plus ferrite. But no perlite in this one. All right, so now between 8.3 and 0.3, so we're in this region here. And so here, we don't form ferrite, we don't form perlite, but we do form bainite. And then again, bainite really doesn't have a completion curve here, and so we're going to form martensite as well. So martensite and bainite. All right, and then and then lastly, faster than 8.3. So we're talking about some curve like this. And so here we completely miss the bainite nose, and we're faster than a critical cooling rate. And so this is going to be just martensite. And so we're going to go back to just martensite. All right, so that's kind of all of the what these microstructures would look like. So you can see that it's very complex here, and then we start to remove perlite and ferrite as we cool faster and faster. So this is kind of what you can expect. This is a fairly complex CCT diagram, as you can see from the curve over here.